Hello viewers, today we are going to start a new topic in chapter number 1, matter in our surrounding. So before we start with the new topic, let's recall our previous video in which we have left 2 points. That point is sublimation and latent heat of fusion. So first of all, what is the latent heat? See, sometimes when you start melting the ice, we all know the melting point of the ice is 0 degrees Celsius, right? So when you are going to start melting the ice, might be you have observed that once the ice starts melting, then after also there is no rise in the temperature, there is no increase in the temperature. मतलब कि जब आप आइस को मेल्ट होने के लिए रखते हो, जब आइस मेल्ट होना स्टार्ट हो जाता है, उसके बाद भी अगर आप थर्मोमीटर में टेम्परेचर देखोगे, then it will not going to be raised. So still you are providing the heat. Heat is continuously you are going to provide. After the melting point, even the temperature is not going to be increased. So the question is arising in our mind where the heat will go, right? So जब तक पूरा आइस मेल्ट नहीं हो जाता तब तक टेम्परेचर इंक्रीज नहीं होगा. Why? Because the heat is utilized by the particles of the ice to overcome from the force of attraction. मतलब कि जो हीट आप कंटिन्यूसली प्रोवाइड कर रहे हो, दैट हीट विल गोइंग टू बी यूटिलाइज. जो पार्टिकल्स, आइस इज इन अ सॉलिड फॉर्म, सो द पार्टिकल्स आर टाइटली हेल्ड विथ ईच अदर. सो टू सेपरेट दैट पार्टिकल, दैट हीट विल गोइंग टू बी यूटिलाइज, and because of that reason heat is utilizing to overcome the force of attraction. There is no increase in the thermometer. It means it is a hidden heat, right, which is not shown in the form of increase in thermometer, and that is the reason it is called latent heat. Latent means hidden, right? So that's why this kind of heat energy which is used to overcome the force of attraction between the particles, that kind of heat is called latent heat. Here the heat is involved in case of fusion. That's why the heat is called latent heat of fusion. Same way you can go through the latent heat of vaporization until the vapors, all the liquid not converted into vapor, there is not increase in the temperature. Why? Because the heat is utilized to overcome the force of attraction, and that is called the latent heat, right? The second topic we have missed, that is the sublimation. So sublimation means what? We have seen in our previous video that solid can be converted into liquid, liquid can be converted into gas. But here the phenomenon is that solid is directly converted into gas, right? That is called sublimation. We have seen that solid, when you are going to increase the temperature, gradually converted into liquid, and then liquid, when you are going to still increase the temperature, it is converted to gas. But here the phenomenon is that solid is directly converted into gas without the conversion of liquid, and that kind of process is called the sublimation, right? So previous two missed topic has been over. Now let's start with the new topic. So the new topic is effect of change of pressure. In previous video we have seen the effect of temperature. Here in this we are going to see the effect of change of pressure. So if you are going to increase the pressure and reducing the temperature, then what happens? Obviously the state of matter will going to be changed from solid to liquid, liquid to gas, right? But depend, either you are increasing or decreasing pressure or temperature, right? Suppose you are increasing the pressure and reducing the temperature, then what happens? Here we can understand this concept with the help of given figure. See, here you can see the particles of any of the matter are little bit away from each other, right? But if you are gradually going to apply the pressure, then what happens? You can go through the figure that the particles have come closer to each other, right? In third figure you can see how much the particles comes closer to each other, right? So it means once you are going to apply the pressure, the particles are come closer and closer to each other, and we all know if the particles are come closer to each other, then definitely it will going to change its state. Suppose we are considering this is as the gaseous state, right? So in gaseous state, what happens? The particles are far away from each other. On this gaseous state, by reducing the temperature and increasing the pressure, what happens? The particles are come quite closer to each other. So if the particles are quite closer to each other, it means it is in a liquid state. And still, if you are going to reducing the temperature and applying the pressure, then what happens? Particles are come more and more closer to each other, and it might be converted into solid state, right? So this we can call the effect of pressure. Once again we recall it that increasing pressure, reducing temperature can change the state of the matter. Now moving to the next topic, that is the conversions of the state of the matter or changes in the state of the matter, what it is called, right? So let's start with first, if the solid is converted into liquid, right? If the solid substance is converted into liquid substance, then that phenomenon is called fusion, right? Solid to liquid is known as the fusion. But opposite to that or inverse to it, if the liquid is solidified, if the liquid is converted into solid, it means water converted into ice, then that procedure is called the solidification. Understood? If we want to remember this with the example, then ice into water is called fusion and water into ice is called solidification, right? Next, let's we move with the if solid is converted into gas. Right now I have explained you that if solid is directly converted into gas, then the procedure is known as the sublimation, right? Okay. Inverse to it or opposite to it, if gas is directly converted into solid, then it is called the deposition, right? If gaseous particle directly converted into solid and deposited on the surface of any of the thing, then it is called the process of deposition, right? Okay, this is the deposition. Now next, if the liquid is converted into gas, right? So, as we all know since a lower standard that if liquid is converted into gas, then the process is known as the vaporization. But inverse to it or reverse to it or opposite to it, if the gas is converted into liquid, then also we know in the water cycle, if the gas is converted into liquid, then that process is called the condensation. By this process we are getting the rain in water cycle, we have understood, right? So if the gas is converted into liquid, the process is called the condensation. So understood this transaction or conversions, okay? Now let's move to the next topic, is called evaporation. It's a very common word since a lower standard we are studying what is the evaporation. So basically we all know the definition of evaporation, that when water is converted into its water vapor at a particular pressure and temperature, then it is known as the evaporation. So basically fine, we all know. Now what we need to see that the factors affecting evaporation. There are so many kinds of factors by which the evaporation is affected. It means either the rate of evaporation increases or the rate of evaporation decreases. So that depends on the factors, right? So first factor, let's see. First is an increase of surface area. Suppose you are going to increase the surface area, then what happens? Evaporation rate will going to be increases. See, while your mother putting clothes for drying, obviously she will going to separate it. She will going to be opened up the clothes, not folded clothes. It not can be put for the drying, right? You have never seen that the rubbed clothes or folded clothes put for the drying, right? It is not happen. First of all, the clothes will going to be opened up and then it will put for the drying. As the same way, suppose we are doing some experiment. I am having a 100 ml of water in a test tube and same 100 ml of water in a glass jar, a wide surface area containing glass jar. So let's put it for a few hours in a sunlight. So after few hours when you are going to observe, then you see there is a decreasing amount of water is more in glass jar as compared to the test tube. Why? Because the surface area of the test tube, or you can say the mouth of the test tube, is smaller. So the rate of evaporation will going to be decreases, while the surface area of glass jar is wider than test tube. So the evaporation rate is more in that. So loss of water is also more in that. So like this kind of experiment can get you the idea about the surface area. When surface area increases, the rate of evaporation is also going to be increases. Next, an increase of temperature. Definitely in previous topic also we have understood that while you are going to increase the temperature, kinetic energy of the particle is also going to be increases, and once the kinetic energy of the particle is increases, particle will start moving here and there. Because of that reason, they are having the space between them, and gradually it is converted into gaseous form as they are having a far space between them, right? So once you are going to increase the temperature, it means you are going to provide the heat, and kinetic energy of the particles is also increases, and particle will start moving here and there, and they can be converted into its vapor. Next is a decrease in humidity. So see, air around us can hold a particular amount of humidity. So if that particular amount of, or a definite amount of humidity is already present in the atmosphere, then no more water vapor can be generated. So it means if the humidity rate is high, then the evaporation rate is slower. But if the humidity rate is low, then the evaporation rate is also higher, right? Because the air around us can hold a definite amount of humidity, not more than that, right? Okay. Now next is an increase in wind speed. That also we can understood while your mother putting clothes for drying. You can see in a windy day, the clothes will dry speedily, especially in monsoon season. See, in a monsoon season, what happened? Your mother used to dry your clothes in a certain room by switching on the fan, right? Because outside there is a rain, so we cannot put clothes for the drying. But inside the home, there is no wind because the closed doors, walls, rooms, etc. So what she will do? She will put the cloth for drying and switching on the fan. So what happened? Because of the wind, the clothes can be dried easily, because wind will also help to get the particles away from each other, and that is the reason that the cloth will dry easily. Same way you can do one more experiment, that having a same surface area jar. In that jar, if you are putting 100 ml of water, one jar keep it in a cupboard or in a closed area, and one jar keep it in a open area where the wind is moved, right? Wind is there, right? So after few hours, if you are going to observe, then the jar you have put it in the cupboard or a closed area having a low rate of the evaporation, but the jar you have put in the open area where the wind is there having a more rate of the evaporation. By this experiment also you can get to know that the wind speed increases the evaporation. Now next, there is a question in your textbook, that is, how does evaporation cause change? So evaporation causes change. Which kind of changes it will cause? See, not change but the cooling. See, how does evaporation cause cooling? We can understood this by activity. That activity is when you are putting acetone in your pan. अगर आप acetone को अपने हथेली पे रखोगे, then what you will feel? Definitely you will feel that your hand is very cold. So how it is happen? See, it is happen because when you put the acetone on your pan, the particles of acetone will absorb the energy from your hand, or you can say will absorb heat from your hand. Once the energy in form of heat absorbed from your hand, what happen? Definitely, obviously you will feel cool, right? So same reason is there behind the evaporation can cause the cooling. Why? Because see, right now the summer season is going on, so our body is sweating more and more. So sweating, what happen? That from your body, the particles of water will get the heat, right? So your body heat will going to be absorbed by the water particles. So obviously your body temperature will going to be decreases, and you feel quite cool during the summer season because of the sweating. Sweating means a kind of evaporation from our body. Exactly the same way, when the evaporation is taking place around us, it means the water particles get converted into vapor. तो मैंने जैसे पहले भी बताया कि वाटर पार्टिकल्स को वेपर में कन्वर्ट करने के लिए क्या चाहिए होता है? एनर्जी, दैट इज हीट. सो फ्रॉम वेयर इट विल गेट द हीट? It will get the heat from the surrounding in form of energy. So if the water particle absorb the heat from the surrounding in form of energy, then definitely the temperature will going to be decreases and we feel cool, right? So that is the fundamental concept behind we feel cool during the evaporation. Okay. Now next question is that why should we wear cotton clothes in summer season? See, your mother used to give advice that wear cotton clothes now the summer season is going on. Do not wear the synthetic clothes. Why? Because when we wear cotton clothes during the summer season, we feel comfortable. Why? Because in summer season our body is sweating more and more by absorbing the heat of our body, and that wetted skin, if it is a water vapor or the water droplets coming out from our body, it is not going to be absorbed by our clothes, then we feel wet and we are not feeling comfortable, right? Because the synthetic clothes having a low water absorbing capacity, while the cotton clothes having a more water absorbing capacity. So if you wear the cotton clothes, your body sweat will going to be absorbed by the cotton cloth and you will feel quite comfortable, right? So that is the reason we have advised you to wear the cotton clothes during the summer season. Now the last question from this chapter in your textbook is, why do we see water droplets on the outer surface of a glass containing ice cold water? See, we have all done this activity. How? See, we used to take out the water bottle from the refrigerator and we forgot to keep it again into the refrigerator. So after some time, when we are going to observe that water bottle, we see so many droplets are put there on the surface of the water bottle, right? So while we are child, at that time we are thinking from where this water droplet has come, right? So but nowadays we know that the answer that the water droplets is on the surface of the water bottle is because there is a water vapor surrounding the air. In surrounding the air, water droplets will already there in form of water vapor, right? So suppose this is the water bottle and water vapor from the surrounding. When it come closer or when it come in contact with the surface of the water bottle, what happens? Water bottle is very cold and water vapor come close or come in contact with the water bottle surface, then the water vapor will going to be cooled down. And once the water vapor will going to be cooled down, then what happen? It is converted into liquid, and that water vapor which is converted into liquid is deposited on the surface of the water bottle in the form of water droplets, right? So that is the reason we find the water droplets around the water bottle which is very cold, right? Same thing is happen when we are taking out the ice container. Same thing happen when we are taking out any of the liquid or any of the substance which is cold. When you are going to put in the normal atmosphere, all the water vapor surrounding or all the water vapors in the air come in contact with that container. As the container is very cold, the water vapor is converted into liquid, and that liquid in the form of droplets deposited on the surface area of that container, right? So that is the basic funda. So finally we are completing the chapter, that is the chapter 1, matter in our surrounding. In our next video we will start with the new chapter. Till then, stay safe, stay happy and stay at your home. Thank you, viewers.